So in the last few lessons, we've gone over how to solve different types of equations and inequalities. So we've done linear equations and linear inequalities, and absolute value equations and absolute value inequalities. Today we're going to go over a new type of equation. So we're going to go over how to solve what we call a radical equation. Recall back when we talked about expressions, we went through radical expression, or radicals in expressions. A radical just means a root, so square root, cube root. In this class, we're going to focus on just solving square roots. Go ahead, I want you just to give this a try. Most of us, I think, instinctively know how to solve this equation. So pause the video, and I want you to see if you can figure out how would you solve for x here? How would you get x by itself? So pause it, give it a try, then come back and we'll talk about it together. So we want to get x by itself, right? So we have the square root of x minus 7. We're first going to get the square root by itself. So I want to get this part by itself. So I'm going to get rid of the minus 7. There's my equal sign. So I'm going to add 7 to the other side. That would give us the square root of x. That would be 0. Negative 5 plus 7 is 2. And now think about how do we get rid of the square root. Well, the inverse of a square root is a square, right? So I'm going to square both sides. So I get square and square root cancel out. They're inverses. Equals 2 squared is 4. And that looks like my solution. Let's just check and see. If I take 4 and put it back in, I get the square root of 4 minus 7 equals negative 5. So let's try that out. Square root of 4 is 2. Minus 7 equals negative 5. 2 minus 7 is negative 5. So it checks off. When I plug 4 in there, it works. It gives us a solution to the equation. Let's try another one. Sorry, that's kind of small. If we take this, I have 7 plus the square root of x minus 3 equals 5. So again, I'm going to start out just by getting that square root by itself. So I'm going to minus the 7. 7's a separate term, so we subtract it over. So I get, that would be 0. Square root of x minus 3 equals 5 minus 7 is negative 2. Now I've got to get rid of the square root and the minus 3. I can't get, the minus 3 is inside of the square root, so square root's got to go first. So I'm going to square both sides. So I end up with x minus 3, the square root and the square undo each other, equals negative 2 squared. That's a positive 4. Then finish solving for x. So I'm going to add the 3 over, so x equals 7. Okay, let's just check and see if that works. So go back up to the original problem. I have 7 plus the square root of 7 minus 3 equals 5. So that'd be 7 plus 7 minus 3 is 4. So square root of 4 equals 5. 7 plus 2 equals, well, hold on a second. That is not equal. Right? 7 plus 2, if it was 7 minus 2, it would work, but it's 7 plus 2 doesn't. So this brings up a really important point, is all the steps I did there were correct. That is how we solve radical equations. When you get to this step right here where you square both sides, so this step right here, when you square both sides, that can sometimes give you a false answer. So even though I did the steps correctly, I ended up with an answer that doesn't work. By the way, this is the only possible answer. So the only possible answer is 7. If it doesn't work, that means this equation is no solution. Nothing will work. This brings up a good point then. When you're solving radical equations, you have to check your answer every single time, because you can do all the steps correctly and get one of these false answers. So these false answers are called, those false solutions are called extraneous solutions. So go ahead in your notes where you have extraneous solutions. If you want to put underneath here, another way to think about it is, I was going to put false answers, but I think I'll put false solutions. So you can do all the steps correctly, work all the way down through it as you should, and sometimes through no fault of your own, you get an answer that doesn't work. So moral of the story, if you're solving a radical equation, you have to check your answer. All right, let's just do a couple more. Make sure we get the steps on how to do this. So it says, solve each equation, remember to check for extraneous solutions. So that's just reminding us to check to see if you have a false answer. Okay, so let's do this one right here. I'm going to slide it over just a bit. But as I go down through this, I want to get this radical by itself. That's our first step. I've got to get rid of the minus 6. Since it's a separate term, I'm going to add 6. That would be 4 equals square root of k plus 1. Take both sides and square it to get rid of the square root. 16 equals k plus 1. Just finished solving from there, so I'm going to minus 1 over. So k is equal to 16 minus 1, which is 15. Before I put that as my answer, let's make sure it works. Go back up to the original problem. Negative 2 equals negative 6 plus square root of 15 plus 1. Let's see, that 15 plus 1 is 16. The square root of 16 is 4. So I end up with that, and that checks off. Right? Negative 2 does equal negative 6 plus 4. So we're good. That is my solution. Let's just do 1 or 2 more. I'm going to skip past. Well, let's actually do that one. I have 4 times the square root of x plus 9 equals 4. Remember, get the square root by itself. I want this part by itself. This time it's 4 times that. Is not a separate term. It's multiplied by it, so I have to divide by 4. Those 4's reduce down to 1. It goes away. Okay. Now when we get to this step, now the square root's by itself. I square both sides. So I end up with x plus 9 equals 1 squared, which is 1, minus the 9 over. Hey, let's double check and see if it works. So the question is, does 4 times the square root of negative 8 plus 9, does that really equal 4? It's supposed to be a 9 there. So let's try that. Negative 8 plus 9 is 1. Hey, the square root of 1 is 1, and 4 times 1 is 4, so it checks off. Okay, this one does work. Hey, let's get past this next one. That one's really similar to the other ones we've done. Let's try this one here. So I have the square root of 4 minus 2p is equal to 4. So first, get the radical by itself, get the square root by itself. This one already is by itself. So now, get rid of the square root. So I'm going to square both sides. So I end up with 4 minus 2p on the left side. 4 squared is 16 on the right side. Now this is a matter of just solving an equation. Get p by itself. So I'm going to minus 4. Negative 2p equals 12. Divide by negative 2. So p is equal to negative 6. Let's check and make sure it works. Square root of 4 minus 2 times negative 6. Question is, does it really equal 4? Times those two together, it'd be 4 plus 12. 4 plus 12 is 16, and the square root of 16 equals 4, so it does check off. I think on the rest of these answers, they all work, but we have to check it each time. We can't just assume that. I'm going to skip past that one. Well, let's do this one right here. So this one's a little bit different. Before, we always ended up with the square root equals a number. On this one, you've got the square root equals a square root. So I've got to go through and find how this works. So all I'm going to do is just square both sides. When I do, the square cancel off on the left side, and this works out kind of nice because the square and the square root also cancel out on the right side. So I got rid of both of them in the same step by squaring both sides. Okay, now to solve for b. So I'm going to minus this 2, get the b off one of the sides. I'm going to minus 2b to get rid of that. 3b minus 2b is 1b. Divide by 1. I guess I don't really need to divide by 1, but b equals 1. So let's check and make sure it works. So I have the square root of 2 times 1 plus 1 equals the square root of 3 times 1. Let's simplify it. That would be 2 plus 1 is 3. 3 times 1 is 3. Well, does the square root of 3 equal the square root of 3? Absolutely. Okay, so we got our answer right there. So if you have a single radical, a single square root, get it by itself first. Then you square both sides, get rid of the square root, and you finish solving for the variable. If you've got square roots on both sides, like that example we just did, you just square both sides, get rid of the square roots, solve the remaining equation, and you got your answer. The one thing to remember, though, on all of these is you have to make sure that you check your solution or check your answer, because you can have those false answers, or we call them extraneous solutions. All right, thanks.